Hey y'all. Today we're going to be taking a look at domain and range. So I'm going to start this first video just doing some graphs on paper so I can point and do all the kind of stuff to hopefully help you out. And then in the next video, I'll show you on Desmos how you can get the same answers and all that good stuff and what you're looking for if you're looking at a graph up there. So here we go. So domain is all possible x values. So what can your x be? Can x be anything greater than 5? Can x be anything less than -2? Is x any number? And range is your possible y values. So same thing, is y less than -7? Or is y greater than 10? Or can y be anything? So domain is your x and range is your y. So we're going to take a look at a few graphs here and we're going to label what the domain and the range is based off of our graph. So this first one is a parabola. It's a little lopsided because I drew it in, so bear with me. So this is a quadratic equation, and it's a parabola when we graph it. So let's start with the domain. Domain is what can your x values be. So if I'm looking here, this x, this side of my U shape is going to get wider and wider and wider and wider and wider. So it's going to take care of every single positive number that you even can imagine because it's going to get wider. Same concept on this quadratic. This side is just going to branch out and get bigger, bigger, wider, wider, wider. So it's going to take care of all the negative x values. So this side is your positive x's. This side is your negative x's. So my domain for this particular graph is any real number. So I'm going to abbreviate domain. Okay, domain is all real numbers. You might also see it written negative infinity to positive infinity. We are speaking the same language. If you want to put in all real numbers, if you want to put negative infinity to positive infinity, same thing. Now, of course, if it's multiple choice, you'd have to choose, if it's written out like this or like this, you'd have to choose the appropriate one. But both of these say the same thing. So my domain for all quadratic functions is all real numbers because they're just going to get wider and wider. Now, your range depends on what the parabola looks like. So for this particular problem, we're looking at the y for my range, and this parabola does not get below the x-axis. So if I kind of draw in, I'm going to use black here. Hopefully it'll show up a little bit. So the black that I kind of made darker here, this parabola does not get below this point. It's not down here or down here or down here. This parabola does not get below this point. So my range is from this number up. So how do you say from this number up? It's from 0 all the way to infinity. So my range is anything greater than or equal to 0. And you might also see it written 0 to infinity. So if you want to write y is greater than or equal to 0, or if you want to write from 0 to infinity, two different ways of relaying the same message. So 0 is included because 0 can be part of my parabola, and it goes all the way up to infinity. So that's the first example. Right. Example 2, I got a vertical line here. The equation for this vertical line, 1, 2, 3. So the equation for this vertical line is x equals 3. So we're going to go through and figure out what the domain and range is. So let's start with our domain. Domain is what can x be. So I'm just going to highlight some points and hopefully that'll kind of make some connections there. So say I want to know what this point right here is. So this point is 1, 2, 3. This point is 3, 3. So x is 3 and y is 3. So this point is 3, 3. Okay. Let's come down here and see what this point is. Okay. This point is 1, 2, 3. And if I count 1, 2, 3, 4, 5, 6. So this point here is 3, -6. And let's do one more and then maybe it'll kind of click for you. So this is 3. If I go up, let's say this point is 3, 5. No matter where I go on this vertical line, no matter where I go, my x value is 3. So my domain for this domain is the number 3. And if you want to write that out with some brackets and such, it would be just like that. So my domain for this problem is 3. It'll never be 4, -7, -200. No matter where I go on this vertical line, my x value is just 3. So if you have a vertical line, your domain is just going to be a number. Now let's take a look at our range. Range for this problem is going to be your y values. Your y values can be anything. When you're looking at your y values, or you're looking how far your graph goes up and down. This graph is going to keep going up, up, up. That's what this arrow means. And it's going to keep going down, down, down. So my range is any and everything. So it's all real numbers. Or you can write it negative infinity to infinity. 2 different ways of saying the same thing. So my domain is just the number 3. So if you want to write it with brackets and parentheses, you would just put brackets around it because it's included in our answer. Parentheses means it's not included in our answer, and it mainly just goes with like the infinities because infinity goes down or up forever. Down if it's negative, positive if it's up. Now let's compare this to a horizontal one. So this is a horizontal line. The equation for this horizontal line is 1, 2, 3, 4, 5, 6, 7. So this one is y equals 7. We're going to go through and find the domain and range for this function. So let's look at our domain. Domain is what can x be? Well, this arrow is going to keep going and take care of all the positive numbers. This arrow is going to keep going and take care of all the negative numbers. So my domain is all real numbers. All real numbers. And if you want to write it in set notation with infinity and negative infinity, you would just write it just like that. So this means I start at negative infinity, go to positive infinity forever. Now let's take a look at our range. No matter where you travel on this line, your y coordinate is going to be 7. This is 0, 7, 1, 7, 2, 7, 3, 7, 4, 7, etc. This is negative 1, 7, negative 2, 7, negative 3, 7. No matter where you travel on this line, your y coordinate is going to be 7. So my range is 7. Now let's compare the vertical with the horizontal. Hopefully you see that they're just flipped. So my domain for a vertical was just a number. My range for a horizontal is just a number. My range was all real numbers up here, but it was domain was all real numbers down here. So you're just looking at your graphs and trying to figure out domain. How far left and right am I going? Range, how far up and down am I going? Let's take a look at a couple more. So this one is a linear function. It's actually the basic function. So this is actually y equals negative x. It's a linear line. It goes through the origin, and my slope is negative 1. Domain and range for this is all real numbers. All real numbers. And in set notation, I can write it like this. And the same for my range. My range is going to be all real numbers as well. If I can spell today, real. All real numbers. And it goes from negative infinity to positive infinity. So the reason I know my domain and range are both all real numbers is because my arrow is going to go up, 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 up forever and take care of every single negative x and positive y. This is going to go down, down, down forever and take care of every single positive x, negative y. So all numbers are going to be taken care of. There's no gaps or holes. Domain and range are both all real numbers. And for any linear function, despite the direction or the slope, is going to be all real numbers. And the last one. This is a square root function, a radical function that we'll take a look at a little later in the semester, but we can still figure out what our domain and range is. So domain is what can x be. So if I'm looking at my domain, 1, 2, 3, this graph, I'm doing this in the red here. This graph does not go past this red line. So pretend it's like a wall there. It does not go past this line. It'll never be 2, 1, 0, -1, -2. Nothing's over here. It's a gap. It starts here and it goes to the right. So how do I say that? So this number is 1, 2, 3. My domain is going to be anything greater than 3. So anything greater than, and it can actually be 3, so equal to. So my domain is going to be anything greater than or equal to the number 3. And if you write that out using interval notation, I would say it includes 3 and goes up to infinity. So x is greater than or equal to 3. It includes the number 3 and goes up to infinity. So my graph will never get past the number 3. Range, you're looking top and bottom. So this graph does not get below the x-axis. So if I draw, I'm going to try to darken this for you. So this little section here, pretend it's a wall right here too. This curve does not get below this x-axis, this horizontal line. The graph is not down here anywhere. So my range is from here up. So my range is greater than or equal to 0. And if I write that out, it would be 0 to infinity. So that is just a few examples with domain and range.